Okay, I wanted to do a quick video to talk about some of the things on the review. So this is our answer key for the review. I'm going to go through problem number 1, and then we'll talk about a couple things on some of the others. So problem number 1 starts right here. Given the following functions, find the requested forms. I need factored form, standard form, and vertex form. I need all those forms. Okay, and then give the information from those different forms and do a graph. So first of all, notice the function is not in standard form yet, but if we make some minor changes, just change the order, we will have standard form. So there's standard form. Y equals ax squared plus bx plus c. A is 1, b is 14, c is 13. Okay, so that's the standard form. Then I'm going to go ahead and find factored form. I'm going to find some information from this in just a minute, but I want to find the factored form. So we're going to factor that. So we're going to do a times c. That's 1 times 13, which is 13. I need 2 factors of 13 that add up or sum to 14. That'd be 1 and 13. Okay, I'm going to draw a box. And in that box, I'm going to make that box a little bit smaller. I'm going to put my first term, last term, the x squared and the 13. And then the middle term, the 14x, gets split into a 1x and a 13x because they add up to 14x. Find the greatest common factor for each row and column. X squared and x have a common factor of x. 13x and 13 have a common factor of 13. Find the greatest common factor for this first column. X squared and 13x have a common factor of x. X and 13 have a common factor of 1. So my factors are x plus 1 and x plus 13. Double check your answer. It does work. Okay, so we're going to have f of x equals, one of the factors is x plus 1. The other one is x plus 13. And there's our factored form. Okay. Now to find the vertex form, we're going to do this a little bit differently. I'm going to come back over here to my standard form space where I actually have some room to work. And I'm going to go back to a different color here for a second. I think we'll go with the red. You know what? We can see this easily enough. It's a big enough screen. So the x coordinate of the vertex, the h, remember the vertex is h comma k. H is negative b over 2a. And when I have it in standard form, that's where I'm going to find the b and the a. B is the 14. A is the 1 that's in front of the x squared. That's negative 14 divided by positive 2. Negative 14 divided by 2 is negative 7. So that's the x coordinate of the vertex. To get the y coordinate of the vertex, we just plug the negative 7 back into the function f. So everywhere there's an x, I replace it with a negative 7. We have negative 7 squared plus 14 times negative 7. Oops, negative 7. Struggle is real. 14 times negative 7. Go ahead and do that calculation. Plus 13. Okay, that's going to get me a k value of 49, take away 98, which is negative 49, plus 13 is negative 36. All right, so my vertex is negative 7, negative 36. Okay, so we'll write this over here where this vertex spot is. Negative 7, comma, negative 36 is our vertex. There's the h and the k. The axis of symmetry is x equals negative 7. Vertical line through the vertex. We'll just fill in some of this information right now. And then we'll do our vertex form. Domain is all real numbers. You know what? I think I'll just use the symbol capital R with the extra line because it's shorter. Capital R, extra line, set of all real numbers, right? The y-intercept is 0, 13. We go up to the function and we replace the x with a 0. We get 0 plus 13, which is 13. That gives us our y-intercept. Replace the x with 0. Parabola opens up because a is positive. A is a positive 1. Okay, the range is going to be everything greater than or equal to negative 36 because my parabola is going to go from a low value at y equals negative 36, right? Negative 36 is the smallest y value, and it's going to go up from there. So y is greater than or equal to negative 36. We've got the range. X-intercepts. I can get those from the factored form. X-intercepts will happen when one of the two factors is equal to 0. First factor will equal 0 when x is negative 1. Because x plus 1 is equal to 0 when x is negative 1. Just subtract 1 from both sides. You get negative 1 comma 0 for one of them. For the other one, you get negative 13 comma 0. My vertex is a minimum because the parabola opens upward. And I have to have vertex form. Well, remember, the vertex form is just f of x equals a times x minus h squared plus k. I need the a, the h, and the k. I've got them already. Let's write down what they are. A is 1. H is negative 7. We found it over here, right? K is negative 36. We'll plug those numbers into this little formula. The standard form formula. Not standard form. Which form? The vertex form. Okay. We'll plug in the a. I'm not even going to write the a. X minus negative 7. Subtracting a negative 7 is the same as adding 7. And there is our vertex form. Right? And we've got all the information we need. The only thing left to do is the graph. So, because I do not have room to go down to negative 36 by counting by ones, I'm going to actually count by fives. I can't even count by twos and get there, right? So I'm going to count by fives. 5, 10, 15, 20, 25, 30. Yep, that'll get me there. So I'm going to go negative 5. You got to mark the scale that you're using. Negative 10, negative 15, negative 20, negative 25, negative 30, negative 35, negative 40, negative 45, negative 50 is the bottom. So at the top, we must be at 50. 5, 10, 15, 20. Yep, we're counting by 5. And there's 10 little tick marks. Okay, so on the x-axis, I'm going to count not by ones because I'd like to get over to that x-intercept at negative 13. So I'm going to count by twos. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we got 20 all the way out here. That's my 8. And I'm going to go down negative 2, negative 4. It's hard to write on this little space. Negative 6, negative 8. My axis of symmetry is going to be halfway in between those guys. So I'm going to draw that in at negative 7. Axis of symmetry, x equals negative 7. Halfway between the negative 6 and the negative 8. Okay. Our vertex is going to happen right down here at just below the negative 35. Just barely below, right? Negative 7, negative 36, right down there. We're going to put some other information on here that we have. We have the y-intercept. Remember our y-intercept 0, 13. So there's 5, 10, 15. We're just not quite to 15. That's my 13. We've got x-intercepts at negative 1 and negative 13. Negative 1 is going to be right there. Let's see, negative 13. Where are we? 8, 10, 12, 14. X-intercept is going to be right there at negative 13. do some counting. And then I'm going to use the fact that I have symmetry. Like we're 1 unit there, right there. Say 1, 2, 3 and a half. Yeah, okay. Reflect to the other side. And I think that'll be enough points. Remember to make it rounded at the vertex. It's not a sharp corner, and it gets steeper all the time. Okay, there's half of the parabola. We'll draw the other half. Again, rounded at the vertex. It's not a sharp corner. And there's our graph. So we are finished with number 1. Okay. I'm going to talk about a couple things on the other 2 problems. Number 2 starts right here. So if you want to find number 2, this is number 2 right here. This is problem number 2. It is in factored form. So you're just going to rewrite the factored form right here. To get the standard form, you're going to have to multiply this out. Okay? Remember we talked about this. You need to multiply out the factored form. I highly recommend that you start here and then distribute the negative. Okay? But I'm going to let you guys do that. And the rest of the pieces are pretty straightforward. The third one, here's number 3. It's in vertex form. Okay, so problem number 3 starts in vertex form. F of x equals x minus h, so h is 3. Plus -1, so k is -1. You got your vertex, okay? I'm going to let you guys finish them up. I'm not going to record any more on this. The solutions, the answer key is available in class or on Canvas.